H is not considered here. You
Yes,
mentioned how, yeah,
yeah, we needed to identify that which type of alcohol it is. Like, is it a 1 degree alcohol, 2 degree alcohol, or 3 degree? So how we will check? Firstly, we saw that at which position OH group is present. Okay, so OH group present at this carbon. Now check this carbon. Is it 1 degree, 2 degree, or 3 degree? This carbon.
so you have this bond that's one, right? And you said there's no
Mhm.
hydrogen.
Where?
The
You only
hydrogens are
need to
excluded.
no, no. We doesn't need it to check hydrogen. We only check how many number of carbons attached to this one. Okay, how many carbons attached to this carbon only?
Just one.
Yeah.
Okay.
Tell me. So is it 1 degree or 2 degree or 3 degree alcohol?
It would be one, right?
1 degree.
Yeah, I'm right.
Then this one. Second one.
Second one, okay, let's see. Where's the main chain? Oh, this one. Oh, this one, it would be a lilac, right?
Yeah. How we
Mm,
identify allylic?
a straight chain with double bond.
A straight chain with double bond.
Like a, right? Like straight chain, like, going like linear. Is that what it is?
We just discussed that. That's what is allylic here.
Yeah, but the thing is, like, this chain is straight. It's not like, how do I explain it? Like, there's no ring structure or anything.
So if there is
Weird.
a ring structure, then it doesn't show allylic, is it?
I think it would be vinylic, right? It's there.
Allylic means a carbon which directly attached to double bonded or sp2 hybridized carbon. That is allylic. It can be in the ring, it can be aliphatic nature. What
Okay.
we needs to firstly check that is there any sort of double bond in the group in the organic compound? Is there any sort of organic double bond in organic compound? If yes, then we'll check that if OH directly attached to double bond, so in that case it will be vinylic. Okay, and if OH attached to a carbon, which carbon attached to a alkene? Attached to alkene. That in that case it it is allylic alcohol. Okay,
Okay, this is the lilac. And then vinylic is just.
OH attached to directly double bond.
Oh, okay, 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 okay. Sorry, they look like really similar.
Hmm.
Mm.
Okay, tell me. So second one is allylic or vinylic?
Second one,
Yeah.
If it's directly attached, then it's allylic, or sorry, vinylic, right?
Hmm.
Hmm. Oh, so then this one, in this case, it would be allylic.
Yeah. Second one is allylic. Then third one.
Third one. Well, there's no double bond here, so I would assume it's neither allylic nor vinylic.
Yeah. So, uh, tell me on the basis of degree. Is it 1 degree, 2 degree, 3 degree?
Um, wait. Neither, vinylic. Hold on, let me get my. Hmm. Wait, are we on question three? We're in question three, right?
Yeah.
Okay. Aliphatic. Number five, it's did we do number three? Right.
Yes.
Yeah, that one was neither allylic nor vinylic, right? So, or what, are we on number four?
Don't also tell me, is it 1 degree, 2 degree, or 3 degree?
Oh, for number three?
Hmm.
Right. I think it's trihydrid
Number three. How?
or C2H5. Oh, C2H5. Oh, wait. C2 dihydrid. Three plus two is 7. Mm, wait. Mm,
How we identify that the given is 1 degree, 2 degree, or 3 degree?
So in my notes, I have what's it called? Monohydric, dihydric, and trihydric. So for monohydric, I have C2H5OH.
No, monohydric means one OH
Oh.
group. Dihydric means two OH group. And trihydric means three OH group. So you need to make notes properly. Just because you are not making notes properly, you are not getting concepts, exact concepts. Okay. You only write down whatever I am writing on the board. You doesn't write down which I am like I gave you some concepts and some sort of
Yeah.
note and all the things. Okay, so that's why you are not able to give the correct answer. Monohydric means one OH group. Okay, one OH group in the organic compound. Dihydric means two OH group in the organic compound, and trihydric means three OH group in the compound. Sorry. Okay, then the next term coming allylic and vinylic. Vinylic means you can note down this thing also. Okay,
Yeah,
vinylic.
vinyl.
Yeah,
Mhm.
vinylic means the OH group directly attached to alkene or a double bonded carbon. Both of them are vinylic. Okay, what is vinylic? Vinylic means a OH group directly attached to a alkene or a double bonded carbon. That is vinylic. Then,
Double bonded carbon. Yeah, I didn't even realize my notes were incomplete like that. Because I usually do like make annotations a lot, especially like make summary sheets like, okay, I'm doing this problem. What's the approach? Why, like in this situation, why does this happen? I do have that. I don't know how I missed that here. That's interesting. Okay. Yeah, I
okay.
have vinylic, and then allylic is just it's connected to it's not connected. It has a double bond, but it's not directly connected,
Yeah,
right? Okay.
there is one carbon more in this case as compared to vinylic.
One carbon more in vinylic, right?
Yes, you can also write down that OH group attached to a carbon, OH group attached to a carbon that directly attached to alkenes, that directly attached to alkene or a double bonded carbon. Okay. Then after allylic, vinylic, mono, di, and trihydrate, the next part is 1 degree, 2 degree, or 3 degree. So in our first class, we discussed that how we calculate degree of any organic
Mm-hmm.
compound. So tell me, what is the degree of alcohol in third question?
Third question here. This one.
Yeah.
Degree of carbon. Mm, It's how many groups are attached, or for the functional group, OH depends on the degree of the carbon that it's attached to, right?
Mm-hmm. Yeah.
I remember that from our first session, yeah.
So the
So
question is,
then,
what is the degree
mhm,
of alcohol in this case? Okay. So degree of alcohol means we need to check the carbon which attached to OH group. Okay. So
mhm.
now we need to identify degree for this carbon. What is the degree for this carbon?
I think it would be primary.
Yeah.
Okay.
Then for fourth question.
Fourth question. Let's see. Oh, okay. Directly attached to the functional group, right? So one, two. I think it would be two here.
Okay, 2 degree.
Secondary.
Yeah. Is it allylic or vinylic?
Mm, directly attached. If it's directly attached to the alkene, right? Then that would
Hmm.
be allylic. Or no, sorry. OH group directly attached to alkene or double bonded C. No, it's just no, this one would be allylic.
Yeah.
Yeah.
So here is the double bond. Okay. Now tell me for fourth or fifth one.
Fourth one. Sorry, fifth one. Okay.
Mm.
Sorry. Okay. The degree here. Carbon is directly attached to one, two. It would be 2 degrees, right?
Yeah, 2 degree, 2 degree alcohol. And is it allylic, vinylic, or anything?
It's directly attached. Directly attached to alkene. No, it would be a allylic.
Mhm.
Allylic?
Is it allylic?
Um, you always make me question myself. I think it is because for what I wrote down about vinylic is that the OH group is directly attached to the alkene,
In
right? For
case of
vinyl.
vinylic,
Yeah.
yeah. So is there any double bond? Yes, here. And the here's the double bond, and this carbon is directly attached to the double bond. Is any OH attached to this carbon?
No.
No. So it is not allylic or not vinylic.
Wait, what do you mean? What's that? What does that mean?
So how
Like,
you are differentiating allylic and vinylic?
mm, a lie. Oh, okay. Alphabetic.
So if I gave you this compound, mhm, this compound. So in this case, this will be allylic. Okay, this is not
Mhm.
allylic and vinylic anything. Do you understand?
Yeah, because it's connected to the double bond, but then the OH
Mhm. Yes,
directly, oh, the OH is attached to the sp2 carbon, right?
that is vinylic. OH attached to sp3 carbon, but sp3 carbon attached to the sp2 one.
Wait, oh my God, that's like a lot of stuff. Can you say that again? It's like a little confusing. It's so similar to me.
So it is sp3 and this will be sp2. Okay.
Yeah,
So
the
whenever
alkene's
OH,
sp2.
OH, when OH attached to a sp3 carbon,
Uh-huh.
which sp3 attached to a sp2, in that case, this alcohol is known as allylic alcohol. Okay.
If OH is attached to an sp3 carbon, which is then attached to sp2.
Yeah.
Um, I see. Okay. This is the lilac. But if the OH is directly attached to sp2, then that would be vinylic, right?
Yes.
Wait, hold on. Let me like so lilac would be OH is attached to sp3 carbon, and that carbon is attached to sp2 carbon in ring. Um, and then vinylic is when OH is attached directly to the sp2, right?
Sorry?
Vinylic is when OH is directly attached to sp2.
Yes.
Okay, that's more clear now.
Okay, now tell me for sixth one.
sixth one. Let's see. You have double bonds, sp2 carbon attached to sp3 carbon. Okay. So then, oh, but the OH is not attached. OH is attached to sp3 carbon. Oh, OH is attached to an sp3 carbon. But it's not attached to the ring. So then vinylic OH is attached to sp2. Oh, OH is attached to sp2. Okay. See, oh yeah. Then it would be um vinylic.
The sixth one?
Yeah.
Are you sure?
Yeah, I think so.
Okay. So see, this is the carbon here. This carbon is sp3 hybridized.
Mm-hmm.
Here is sp2. sp2. Any doubt? So now we are start the reaction part of alcohol, like method of preparation part. So in that part there is 4 to 5 reactions. Okay. Do you have any doubt up to now? This is like introductory part or a little bit basic part of alcohol. So you are getting more about alcohol. Okay. Do you have any doubt up to now in allylic and vinylic?
Wait, hold on. I'm gonna copy down the examples. Mhm. Just to make sure number 5 was allylic, right?
No.
Vinylic, okay.
How it is allylic? See, this is
Yeah.
sp3 and this is also sp3. And here is sp2. Okay.
Okay, I just wanted to double check. Mm, Number four is allylic. Okay. Mm. OH group is attached to sp2. All right. What do you mean by OH? Okay, yeah, I have a question. So, like here, when you're, how are you doing the hybridization? Like, can I see?
If a carbon is single bonded with all the other atoms, then it will be sp3. If there is a double bond in between carbon and carbon, so in that case it will be sp2.
Okay, so this is sp. Like, how do I explain it? Like, when you say that allylic, like when you say OH is attached to sp3 carbon and that carbon is attached to sp2 carbon and ring versus
Mm-hmm.
vanillic OH is directly attached to sp2. Like here,
Mm-hmm.
technically, you have this OH, right?
Mm-hmm.
So, like, is it being when you're considering the carbon that it's attached to the hybridization, are you only considering these two bonds? Or are you
Yeah.
considering OH in that as well? Does that make sense? Like, I don't know if that makes sense. Like what I'm
OH?
asking.
What about like a OH attached to the sp3 and that sp3 attached to sp2?
Okay, so like what I'm saying is, are you including OH in that hybridization or no? Is that separate?
Hybridization for what? Like for carbon?
Yeah, because when you mention OH is then attached to this, is that separate or like are these two things separate completely?
We only see that OH, okay, this is OH, and OH attached to a carbon. Okay, so we are going to discuss about only this carbon. Okay, now this
Mhm.
carbon is having one bond with hydrogen, one bond with CH3, one bond with a ring, and one bond with a OH.
Oh, okay, 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 yeah. So like the full, okay, so carbon and it's full
Yeah.
high, like everything bonded together, including OH. Like OH is a part of that as well,
Sorry?
right? What I'm saying is like OH is a part of the whole hybridization of that carbon, right? So
Yes, yes, yes.
okay, because when I wrote down allylic in my notes, I was a little confused. Like I thought, like, is the OH separately attached to another? Like it was hard for me to recognize the hybridization. I don't know if that makes
Mm-hmm.
sense. Like I don't know if that makes sense, but
Yeah.
I just
Now I'm
wanted to
giving you
clarify that.
okay,
I
wait.
think that was like the main doubt that I had. Wait, sorry, I'm just
Mm-hmm.
gonna like finish. Give me
Yeah.
1 second. Did we do number eight, ma'am?
Yes, let's try with number 8. Okay. So how you will approach this type of question?
Mm,
Hmm.
okay, so you have double. Okay, double. Mm,
How many OH are in the compound? Tell me. How many OH?
all right, just one.
Only one?
Oh, sorry. No, two. I forgot about the ring one. Yeah.
So there is two OH. That
Mm-hmm.
means we need to identify for the two OH group. Okay. So firstly, let's suppose this OH group. So here, okay. So this OH group, here is the double bonds. Okay. These are the double bonds in the ring.
Mm-hmm.
And the OH group attached to double bond directly. So tell me, what sort of alcohol it is?
A dihydride?
Is it allylic or vinylic?
Oh, sorry. I thought you were asking about the OH group itself. Um, lilac. Let's see.
Okay, so
I
how we
think it's
approach this?
a vinylic is the carbon. Oh, carbon is directly attached to double bond, right? This is like a tricky topic, like because they're
Tell
both so
me the
similar.
hybridization for this carbon, the pink one,
Which one?
the
Oh,
pink one.
that carbon is as sp3, right?
sp3. Don't you think it has a double bond, so it will be sp2? Hmm?
One, two, three. But I thought there was like a hydrogen. Wait, one. Oh, sorry. No, never mind. Wait.
No, no. It has
One.
a double bond. So whenever carbon having double bond, it will be sp2.
Wait. Okay. So you're not taking each bond.
No. We can take, but if there is a double bond, then it will be surely sp2 hybridization.
Oh, okay. So then where'd the hydrogen go in this carbon?
It doesn't need hydrogen because it completed its valency. Carbon need four bonds. It make four bonds.
Oh, okay, 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 okay.
Hmm.
Yeah.
So
A
when
double bond.
OH attached, mhm, OH attached to sp2 hybridization, then it is a
Vinylic directly.
vinylic alcohol. Okay, now vinylic alcohol. Now tell me for this one.
Hmm.
Sorry.
I think this one would be
So
a
how
little bit
how we are checking? We check the first the carbon. Okay, carbon attached. Now the carbon attached is sp3 or sp2.
SP SP3.
Yes. and it attached with a carbon which is,
Mm, hold on. SP2, right?
yes. So tell me, is it vinylic, allylic, or any other?
This one, oh, directly attached. This one would be vinylic. No, no, no. Allylic.
Sure. So when O is attached to a sp3, which directly attached to sp2 carbon, so in that case it will be.
Allylic, yeah.
Okay, great. I'm giving you one more question.
Oh, wait, sorry, mom. What did you get for number seven? Oh,
We did
number
number
seven.
7, I think.
Yeah, sorry. I think I couldn't. I wasn't able to write that down. Let me just see.
Okay, okay,
Oh,
you can write
allylic.
down.
Okay. Yeah, got it.
Okay.
I just needed to add something.
Ninth one. Yeah, great. Okay, this is a little bit tough. Okay. And now
Mm-hmm.
you need to identify each and everything very carefully. Okay, let's start with
Mm-hmm.
the first one. This first one. Okay. Now you check this and tell me.
I think number one is allylic.
Okay. So tell me how this carbon
Mm-hmm.
is.
Mm-hmm.
Tell me sp3, sp2, what sort of carbon
Oh,
for
wait.
this?
Oh, so wait, sorry. Give me one second. I'm looking at the carbon next to it. No, I think that's not right. Mm. Oh, okay. This particular carbon is sp3, right?
Yeah. So this is sp3. And this one,
I think that's also sp3.
this is sp3. Think again.
Mm, sp2. Sorry.
Yeah,
Okay,
because it
that's
has
like a
a double
huge,
bond.
yeah.
This one,
sp2.
yeah. Great. So now let's check for the first one. The OH attached to which carbon? Okay, so tell me this one also. These two.
Mm-hmm.
Hmm? All of them are having single bond now.
Mm-hmm.
All the carbons which is in cyclohexane. So all of the carbon of cyclohexane is sp3.
Mm-hmm.
Okay. sp3, sp3. And this carbon where OH attached?
Which one?
The carbon where OH attached.
Oh. Mm, sp2.
Yeah, sp2. This one is also sp2.
Mm-hmm.
And here, this one,
sp3.
yeah, sp3. Now the first one we will start with first one. Okay, let's suppose this is the first one. The first one, OH. OH attached to sp3 carbon is this sp3 carbon directly attached to any sp2?
Mm-hmm.
Hmm?
Yes. Oh, sorry, I'm so loud. Yes.
Yes. So the first one is allylic or vinylic? Tell me.
The first one,
Hmm.
the one you circled, or the in yellow?
Yeah.
Yeah. I think that one is a lilac.
Yeah. So this is allylic alcohol. And this one, OH.
Mm-hmm. That one. If it's directly connected to sp2, I get it now. I see. Okay, that's vinylic.
Yeah. Good. Now let's talk about this one. This one.
Mm-hmm.
Tell me.
Mm, I would be a lilac.
Allylic. Think again.
Oh, it's directly connected to sp2, right? Okay, vinylic. I would say no, I think I would say it's vinylic. Ma'am, are you there?
Yeah.
Oh, okay.
And this one, the last one.
Mm,
Done?
that one. That would be a lilac.
Hmm. Yeah, great. I think now you understand like what is allylic, what is
Mm-hmm.
vanillic. Great.
Yeah, yeah. With the like the whole car, like all the rings and stuff, like I think it makes it easier to see like the difference because otherwise
Mhm.
like it's you can get it very confused a little like
Yeah.
if you're just
Yes.
looking at one single ring,
Mhm.
you know?
We like a majorly whenever allylic and vinylic will come, so it needs to identify hybridization. So I think that is
Mm-hmm.
a little bit more easier as compared to directly check. So whenever we give the hybridization to each carbon
Hmm.
before starting further, so that will be a little bit more easier. Okay. So whenever you start seeing the allylic vinylic concepts is not important in like the examiner doesn't ask you that tell me is it allylic or vinylic. No, in the further when we start reaction, so in the case of
Mm-hmm.
reaction some reagents are there which attack only at allylic position or allylic carbon. Okay, that is the most
Mm-hmm.
important thing. So in that case you needs to know like what is allylic position. Okay, what is
Mm-hmm.
allylic position? What is vinylic position? So we start to introduce these concept before reactions. Okay, so it is like when we are talking about the allylic position, so it is a little bit
Mm-hmm.
familiar to you also. Okay, that this is the
Mm-hmm.
allylic. Okay, any
Mm-hmm.
issue up to now? Anything?
No, I think after this example, it's a lot more clear.
Great, great then.
Yeah, good
Okay,
example.
so mhm. So after
Because
this,
just by like
yeah.
knowing the definition, because like I just kept looking at the definition over and over. It's just not help. It wasn't helping me at all. So I think I needed to see it
Mhm.
like that.
Yeah, you need approach in chemistry majorly.
Mm-hmm.
Hmm. Okay, so this is the general introductory part we completed up to now. Okay, now we discuss our reaction. Okay, one reaction for today. Okay, so how we are like doing the functional groups. Like whenever we discuss, there is a lot of functional group now
Mm-hmm.
in your syllabus,
Mm-hmm.
like alcohol, phenol, and ether, and alkene, all of them.
Mm-hmm.
So see, whenever we are starting with alcohol, so whenever we start any functional group, we first study about their classification, their IUPAC name, their structure, and after that method of preparation and chemical properties. Okay, and this is the
Mm-hmm.
major topics which we are going to cover in each functional group. Okay, So
Sorry, can
now
you
we
see the
start.
name?
Mhm.
Can you see the names again?
Names. Okay. So firstly, we discuss classification. First, we do a classification, then IUPAC, nomenclature. Okay, IUPAC nomenclature. Then we discuss a structure. Hello.
Mm-hmm.
Structure, then method of preparation, and then chemical properties.
Wait, so IUPAC structure, method of preparation, chemical properties, right?
Yeah.
Okay.
Okay. Okay. So now we start method of preparation. In method of preparation, what is the method of preparation? So how we can prepare alcohol from different groups or different things. Okay. Like how we
Mm-hmm.
can prepare alcohol. That is the topic
Mm-hmm.
which we are going to discuss like for 2 days at least. Okay. So let's firstly start with from alkene. Like from alkene, how we can generate alcohol. Okay, that is the topic. In
Mm-hmm.
alkene, so there is three methods from alkene also to generate alcohol. Okay. So the first method is hydration, then oxymercuration, oxymercuration. You note down this thing, and
Okay.
demercuration, oxymercuration and demercuration, then hydroboration, hydroboration, oxidation. Okay, these are the three methods which we are start to discussing from next class. Okay, before next class, your homework is study about carbocation, study about Markovnikov rule. Do you know about this?
Markovnikov's rule? Yeah, I think I've heard of it.
Great. Markovnikov and anti-Markovnikov. Okay, this is your homework. These three things.
Wait, can you clarify your expectation about the homework? Like, do you
Yeah,
always
yeah,
want
yeah, yeah. Mhm.
a certain number of problems to be done before the next class? Like, is that how you expect, or like what, like the next class, right? The next day. Is that's your expectation?
Yes. So a little
Oh,
bit definition and how we can apply theoretical part of carbocation and Markovnikov and anti-Markovnikov. Okay, theoretical part only. And today I'm not giving you any sort of problems, new problems. Okay, because I don't think so that today you need anything because we discussed the problems which I gave you yesterday. Okay,
mm-hmm.
so in next class you need to prepare a little bit about carbocation, like a basic about carbocation, Markovnikov and anti-Markovnikov. Okay, so we are going to discuss method of preparation from alkene and yeah, from alkene we only can cover from like for next class only because alkene, like from alkene to alcohol, it is a little bit more lengthier part. So in next class we only can cover this part. Okay, and yeah. So do you have any doubt up to now? Anything?
Wait, what problems did we cover from yesterday? I'm just curious because
Sorry?
I don't know if I have all of.
The
I think
IUPAC name,
okay. No, no, no.
I
I meant
share you
like the
some PDF,
problems because
some photos.
sorry.
Yeah. Mm-hmm.
No, no, no. I was saying like the exact problems because I don't know if I have the same problem. Like these are the exact problems that we did yesterday. Where
I shared you some pictures yesterday. Do you get that? Like
oh,
homework?
I thought oh, isn't that the homework though, or whatever you was yeah, the homework?
Yeah. So like
Okay.
70 or 80% of from that homework we covered today. Okay. There is, I think there is there is some
Okay.
compounds which is like you need to tell IUPAC for them. So they may be left. So if you want, you can go with IUPAC, but it doesn't uh, really necessary for like IUPAC. IUPAC, you know a little bit, and I don't think so. IUPAC is that much helpful. So you majorly need the classification part, allylic and vinylic concept, 3 degree, 2 degree, 1 degree concept, and yes, this is the major important part up to now which we discussed. Okay, any issue?
Mm-hmm. Um,
Hmm.
no, I was just like I was just wondering like let's say for example for whatever reason like I didn't do the homework like I guess today I couldn't,
Hmm.
but would that majorly stall my progress? I think it would, right?
Yeah, absolutely fine. If I'm giving you some homework, the homework is just for you, like to increase your approaches toward practicing
Mm-hmm.
questions, and
Mm-hmm.
it is little bit give confidence to you also
Yeah,
to attend the next
true.
class. Whenever you do your
Yeah.
homework, it is sorry.
Yeah, yeah, yeah. Because you're coming in with a fresh like mind, like
Yeah.
like you
Yes.
have some knowledge. Yeah, I understand that. Like you have some
Mhm.
knowledge.
Yeah.
So you feel like you're not in the dark. So I think I should probably just be more consistent. I mean,
You are
I
consistent,
was
but like you need to be a little bit more into questions. That's the only
mm-hmm,
thing. Hmm.
mm-hmm.
You are
Um,
attending in class, you are solving doubts, like with a good mindset. Like you know what the concept when I describe in the class. But only thing that you need to do a little bit practice, because yesterday I only share only 2 or 3 questions, I think, because you told me in yesterday class that I'm not able to take a lot of like 14 15 questions and 3 to 4 PDFs.